Hello, welcome back to math. Part 2 is a little bit more work today on different types of graphs. Again, this is going to be a review. I think primarily a review. There's probably one new thing you're learning today, which you might not have seen in grade 4 or grade 5. But the rest of the types of graphs that we're doing today should be very familiar to you already, okay? So there is a little bit of printing to do today, but you guys can kind of skim it down just to getting in the important stuff. So here we begin. All right, first of all, so we're continuing with the same thing. We're just doing review of different types of graphs. The new subheading, so you don't have to write a new, I can't say it's the same. So the new one today, which isn't new, but it's review, is double bar graphs. And bar graphs, like we did yesterday, was actually grade 4, so it was actually pretty easy. And then today, this double bar graph is from grade 5, okay? So basically, it's the same as a single bar graph. It's used to show two or more related groups. So in this case, the related groups would be, okay, the ice cream, that's the related group. They could have done even more than two. They could have put in strawberry there. They could have put in chocolate chip mint. They could have put in whatever, okay? So it could be two, I guess, double bar graph, or it could be like a triple bar graph. I don't think it'd be very common to do more than triple though. Like there could be, but it's just, we're not gonna see those. It's not really very popular. Okay, and then usually the thing is for double bar graph is they would have a legend, which would show different colors to represent either colors or texture. It could also be like small lines going through the graph, or it could be like fully colored in, then not colored in, just as long as there's some visible difference between the two different types according to a legend. So it could be, examples could be, so in this case they showed chocolate versus vanilla, but it could be boys versus girls. That's what's a really common one. It could be all three grade 6 classes. It could be grade 4 versus grade 5. It could be the different house teams. If we had like a, what would that be? A quadruple bar graph if we had 4. Yeah, okay, so there we go. So the same thing. So the bars would need to be in different colors or textures. Okay, the other one thing I want to point out here, we're going to be talking about this later. This is just like a little mini preview. As you notice right here on this scale that they have used, is they've shown this little thing which is called a break in the graph, which is strategic and it's very helpful to use if you have values that don't really show like 1, 2, 3, 4. Say it just like automatically spikes up to like, I don't know, 100, and then it goes like 100, 110, 120. Then you could show a skip. So it's kind of like a slinky. It's like here we've just like squished in the bar graph. And if we show this, then it means that we know that this isn't how the rest of the scale is going to continue. It's just like a shrunken up like set of numbers because we have nothing to represent between 40 and 0. So it just makes the bar graph look a little bit kind of easier to view. So there, we will be practicing those, including those later, but that's just like a little mini preview in this one. Okay, so double bar graph is type 1. Okay, so that could be on a single page. If you want to do a quick little sketch of this, you could. If we were in class, I would have this printed out for you, even in color, which would look so nice. But you guys can sketch that if you would like to. Okay, the second type of graph we're learning about today is a circle or a pie graph. Okay, so the same deal. If we were in class, I would have had this printed for you, but you could just like draw this in or sketch this in. Okay, and the same thing, we'd have to show differences in color or differences in texture within the graph. Okay, now the key thing for this is it displays a percentage of a whole. So that means we have to know what the full amount is to accurately choose to use a pie graph. So for example, like this one, favorite ice cream of all the students, it wouldn't be really very wise to use a pie graph to show that one because, well, what if there's more students that just come to the school, right? Then we might have to have our values going up and up and up. Something like this, what they've done is they've taken a whole group of people and they've said, okay, we're stopping. This is how many people we have. And then we're showing a total out of like 100, which would be out of like a percentage, okay? And usually the way that it's listed is like, okay, so types of movie. Okay, so they had 4 votes, which equated, and this is again kind of like loops back a little bit into our percentage and fractions unit, which would be equivalent to 20%. Okay, So this means, what do we know the denominator would be in this? Can we do some quick math for this? How many people would have been surveyed in this if we know that 4 was 20%? What would it be? What would it be? Can you guys figure this out? It would have been, let's see here. It would have been, let's see, 5, I think it would be 20. Yeah, it'd be 20, right? Because 5 over 20 is a quarter. Yeah, so there would have been a total of 20 people that they would have surveyed here. Okay, anyway, that's just a little side note. Okay, so the next thing is each section represents part of an entire data set. So the entire data set is 20 people, and then this part represents, 4 people, okay? Or as a percentage. Alrighty. The next one is there should be a legend or value should be included as a percent. Okay, so there should be the percentage somewhere listed if you're showing a circle or a pie graph. Okay, there you go. That's it for that one. Okay, the next one, and this is like literally grade 3 or like grade 2 or maybe even grade 1, is a pictograph. Okay, but sometimes these do pop up still. So it's very, 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 very similar to a bar graph, but the only thing that's different is that there's symbols used to represent a value. So instead, and they always would give a legend at the bottom here. So if we had an apple, a full apple, that means there are 10 apples, right? And then half would be, half an apple would represent 5. So this is a little bit limiting because, well, why? Why is this limiting? Would it be easy for us to show 11 apples? Awkward, right? Like it would be really awkward to show like a little slice because it could be misinterpreted by the viewer as, well, I don't know, like is that 2 or is that 1 or is it 3? So it's easy if it's like simple numbers, but it's like, it's just not really going to be quite as accurate. Right, so the value in the symbols must easily be made into half. Yeah, or they could use this for like approximations as well. That might be like kind of like just to show like a rough, it might not be for exact numbers, but just for like an estimate, they might use a pictograph for. Okay, and again, like a bar graph, the values could be displayed vertically as kind of like we would normally see, or in this case, horizontally, either way. Okay, now this is the last one, which is, I don't know if you did this last year or not, but it's kind of cool. It is called a stem and leaf plot, okay? Kind of weird, but still something that I've seen pop up on PATs. All right, so this one involves numerical data that's organized into rows according to place value, okay? So it'll make more sense once I kind of go through this example. Okay, so it helps us to easily see which data range is most common. So like where do we see the most amount of like snowfall, for example? This one's from like Berlin, Germany. And the numbers are always written in ascending order. Okay, so that means we're starting from the smallest number and then we're going up to the biggest number. Okay, so I'm just gonna explain this a little bit further. So, okay, all right, so this is for average monthly precipitation in snowfall in millimeters over the year, so starting from January and then going until December in Berlin, Germany. Okay, so here would be the months below, okay? Oh, this is meant to be a comma. This should be a comma, not a, oops. Okay, whatever. All right, so here's the key. So the stem represents, in this example, the stem represents the tens, right, which is a 3. And then the leaf represents what's in the ones place value. So in this case, this is 38. So if we look up here, the stem, we would know, well, what was the snowfall in like the 30s? Well, we had 38, we had 38 again, then we had 39. What was it in, what was it in the 40s? Okay, and we see kind of like, it also helps us, when this one up here, it says it helps us see the range, what range is most common. Well, we kind of see there's quite a bit in like the 30 to 50 range, right? Not as much in the 60 and then very little in the 70 and none in the 20, I guess, right? So that means that's a lot of snowfall. Okay, so right, then this would be like 41, 42, 48. That's how we would read this. And then here are the sets of data below. So what you might be asked to do is arrange a set of data like this into a stem and leaf plot. So it's always helpful to group it in, yes, ascending order. So from smallest to largest. Okay. I don't think we're going to do this one. A histogram. Okay, I'll just say this to you guys because we're going to go on to something else later. You're not going to have any histogram practice today. So a histogram involves two sets of numerical data. Let's see here. So it can be counted in halves. Numbers can be counted in halves. Okay, so it's right. So this is the main thing. It's like a bar graph, but it's two sets of numerical data. So technically, rather than categories across the bottom, we would have a range of numbers, which would then like be increasing according to like this would be the furthest away, and then this would be like the most present, right? Reading like from left to right. So technically, actually, the recent bar graphs for coronavirus would be actually histograms because they would be showing historical data, right? Like even though it's like historical from just like the past few months, it's still represented by values, numerical values across the bottom, across the x-axis, which would be like days of the month, probably starting in like March type deal, going until now, it'll be continuing. And then up the side, up the y-axis would be number of, it depends what it is, right? Like number of infected people per country, whatever. Okay. Yeah. Okay. So continuous numerical data. Okay. So that means it's always, there could be a half, I guess, in this case. Oh, yeah. Okay. So I guess if they wanted to do this one, they could say, okay, where it was like, I guess for this one doesn't, people example doesn't make sense. There can't be half of a person. Oh yeah. Sorry. It can be counted. Sorry. No halves. Yeah, that's right. So it can't be like 1.5. You can't have 1.5 people. It has to be full amounts. Yeah. Okay, continuous means that it's possible. Oh no, that does not make sense. Okay, I guess it could be this. Okay, so it could involve either people that can be counted or, okay, we're gonna talk more about continuous data later. But as a little preview, continuous data means that there could be decimal places or fractions, which means that, like, for example, if it was like money that you're earning, okay, it's not always going to be like $1. It could be, or like a dirham, it could be like a fil as well. So that would mean that we could show decimals and fractions. Anyway, we're going to talk more about that one. It's always like, what's going to pop up there? You never know. It's a scary moment. Okay, so that's it. I know this is kind of like long. You didn't really even need to write that stuff down if you didn't really want to. It's just review. The 7-leaf plot, though, is kind of interesting. So this is the homework for today. Now, it's going to be similar to yesterday in that I'm not going to say you have to do the whole entire thing. It's going to be like kind of like choose one. So pictograph, okay? So you could choose. Oh, no, okay, so you have to do the pictograph because I only gave you one of them. All right, easy. Now, there's 1, 2, 3 pie graphs to choose between. Oh, no, 4. Whew, if I was really carried away with the kids last year, I probably had them do more than you guys. Okay, so anyway, you can choose one of the 4 pie graphs to do. Your choice, whatever one. Maybe you like doing seasons, maybe you want it to be camping, maybe you want it to be movies, methods of transportation, whatever you choose. Okay, then stem and leaf plot. Okay, I've given you 1, 2 okay, I've given you 4 pages. Let's say this. I'd like you to do either I want you to do either one of these ones. Okay, so either this one about the industries, okay, our air traffic controller, or this one, okay? So either one of these two, okay, because it's just making stem and leaf plots. And then I would definitely like you to do this one where you're interpreting a stem and leaf plot, okay? So, yeah, I'll say that more in like our post for what's due. And then this one's optional. You don't have to do that last one unless you want to, okay? So basically, you're doing one pictograph, okay? Then you're doing one circular pie graph, okay? Then you're making one stem and leaf plot, and then you're interpreting the stem and leaf plot. So same as yesterday, you're doing 4. Okay, there you go. That is it for today. Good job.